Okay, so here we are. We've removed the stock exhaust system, as you can see, and we're working away, starting to work on the Feuling components, work on the engine. We wanted to take a look at the rocker box. The rocker boxes, look at the rocker arms and the springs and so forth. So we did remove the gas tank, and we're going to pull the push rods up out through the top of the engine versus cutting them. We've got the Feuling bulletproof cam chest kit here. Set of 574 Reaper camshafts. We're going with the chain drive models. Feuling HP Plus lifters. High flow Feuling cam plate, part number 8015. High flow oil pump, part number 7060. Set of gaskets and breather setup. New Timken bearings, inner cam bearings, and a set of Feuling fast install push rods, which will also include a little tool to hold the push rod tubes up out of place while you adjust the push rods. Okay, so we removed the rocker arm assemblies to inspect, see how everything looks, and we removed the push rod tubes. So we're now going to remove the lifter block. The thing we noticed is a little machined hole in the exhaust port. It is for the electronic compression releases. It's in both heads. The 2011 has the exact same hydraulic chain drive system as 06 Dynas and 07 and later models. Everything's still the same there. We took apart the new 2011 rocker arm assembly and breather system, and we've noticed that it's a different assembly for the 2011s, requiring different gaskets. It appears to be the same flapper valve as the older models. But it does require new gaskets, as you can see. Okay, we're checking the crankshaft runout. I don't know how well you can see that, but on the high side we're seeing about 4,500 thousandths runout. Okay, we've got this example set up to show you the difference between the Feuling oil pump gears and the factory Harley gears. These are for a late model oil pump, 07 to present, and including the 06 Dynas. As you can see, the scavenge set of gears right here were over 30% larger, and then you've got the pressure set of gears where we're over 20% larger. Kind of give you a view and a difference with the two oil pump gears. The main difference between the two oil pumps themselves, are going to be the size of the gears, but also the Feuling oil pump is made out of billet aluminum versus the stock Harley pump is made out of cast aluminum. The stock Harley oil pump is one housing versus the Feuling oil pump is multiple housings. And the reason we have it set up with multiple housings is so that we can match the gears up to each housing. So we match up the pressure set and the scavenge set. We use the separator plate here to separate the two housings, versus the Harley oil pump uses these two washers as your separator plate, but they use a spring washer that goes in the middle of them to side load the gears, which is what they use to separate the two housings. However, the spring washer side loads the oil pump gears. It side loads it both into the back side of the oil pump, which you see right in here, which is why you'll normally see scoring in there, and on the front side where it side loads into the cam plate. And if there's any debris rolling through this engine, that side loading grinds the debris right into these two housings, and especially with the softer cast aluminum that Harley uses in the oil pump and their stock cam plate. Okay, we're getting ready to install the cam plate. We're working on an A motor, an FL bagger, and so we're going to plug the port on the cam plate. Allen set up here, we put a little thread sealant on the Allen head plug, and that's the feed hole. That is the feed hole on the B engines to feed the tensioners, and so on an A motor we don't need it, and so we just plug it off for safety. That way you don't have to worry about any leakage there and a loss of oil pressure. Okay, we've got a comparison here of the Feuling high flow cam plate next to the factory Harley 2011 cam plate, and these are both for models 07 and present. However, Harley made some changes on the 2011 plate, but I'd like to point out some features of the Feuling plate. For starters, this is a billet aluminum plate, which is made out of a 7075 aluminum, which is over 50% harder and stronger material than what the factory cast cam plate is made of. The Feuling cam plate has much larger kidney shape. And when I refer right here is the kidney shape, that's where the oil pump mounts up to the cam plate at, versus the stock Harley cam plate. We've also got larger oil passages in ours exiting the cam plate, which would match the ports inside the case. Here's one of our ports matched up to the Harley port. You can see the difference. Ours is a direct match, blueprinted match to the cases. We've also added pressure feed holes to the camshaft thrusting surface of the cam plate, and we added that to both the back and the front side. You see the little holes, and then we've also got an oil groove on the inside of the cam bore, which holds oil for cold startup. In comparison with the stock Harley cam plate, there are no feed holes here, and you can already see this is a cam plate out of a 2011 with 2,000 miles on it, and you can see it's already getting scored up, and that's because of lack of oil and that thrusting. So there's no feed hole on the Harley plate, front or back side, and they don't have a groove on the inside of the bore for cold startup. A new addition to the 2011 plate for the Harley is they removed the bushing, the bronze bushing for the pinion shaft, which is something that we removed back in '99 when we started doing cam plates. Generally, with the addition of our cam plate and oil pump to an engine, we see a reduction in cylinder head temperatures somewhere in the neighborhood of 20 to 30 degrees. Okay, we've got a set of Feuling HP Plus lifters. They're our part number 4000. They fit twin cam 99 to present and the late model Sportster engines. And what we want to demonstrate here is the proper way to pump them up. First, we clean them in a clean solvent tank. We make sure that all the rollers feel good, that the roller spins nice and freely, and we'll clean, blow the lifter off, make sure that it's clean, blow the feed hole and the pushrod seat. Okay, what we like to use is an oil squirt can. Another method to use is a syringe. This is the best way to get the lifter pumped up, and it's also helpful to use a lightweight oil, something like a 10-weight oil or even transmission oil. But the key is to get the lifter fully pumped up so that the pushrod seat is rock hard when you go to push it down. But what you want to do is pump it up through the side feed hole, and you want to pump the air out of it. See the air bubbles? And then I also like to pump oil back down through the pushrod seat, watch it come out the feed hole, and then once again back through the feed hole. And what that ensures is, for one, that the lifter is fully pumped up, so you know when you go to start the engine that you're not going to run the internals dry. And second of all, it makes it extremely easy to adjust your adjustable push rods, because now when you go to find your zero lash where you extend your adjustable push rods, that push rod seat's rock hard. It makes it much easier to find zero lash. But the importance here is to get the lifter pumped up, and so you're not running it dry, and you get a good adjustment on your push rods the first time around. Okay, we're going to use Feuling tool number 9015 to check the crankshaft runout on our 2011 bagger here. Feuling tool makes it quick and easy to check the crankshaft runout. Got the indicator mounted to the tool. We just open that up, get the indicator out of the way, slide it over the crankshaft. Use our quick thumb screws to attach the plate, solid mount it right to the case so we get a good accurate reading. And you can also notice that we screwed the pinion bolt back into the crankshaft, so it allows us to turn the crankshaft over nice and easy. We're going to set the indicator to 0 here. And then we're going to rotate it over. We're going to see what we have. Looks like we're right there about 4.5 thousandths. There you have it. Okay, we're going to check the lifter bore measurements here on the 2011 CVO project. Alan's got a snap gauge in his hand. He's going to take a couple measurements of each bore, and we take an average. The snap gauge is the easiest, or probably the most common way to measure it. A dial bore gauge is going to be the best, but this is the most common out in the field. Take a couple measurements of the snap gauge in a couple different locations and kind of take an average. With the Feuling HP Plus lifters, we like to see a lifter to lifter bore clearance of a 1 to 1.5 thousandths. The closer you are to a thousandths, the better pressure the hydraulic lifter. Okay, we've got our complete cam plate, oil pump, camshaft assembly ready to install. We've got the hydraulic tensioner, the chains all complete, and a lot of assembly lube inside the oil pump, on the cam plate face, and so forth. But one thing we did to ease the assembly is we've lined the flats of the oil pump gears facing straight up towards the camshafts. And if you come over here and take a look at the way we've lined up the crankshaft flat, it's facing straight up. And we've also got lots of lube in all the areas, but by having the flats both lined up on the oil pump and on the crankshaft, there is going to ease the assembly process. Okay, so we got the cam plate assembly installed, and we're rotating the engine over while we tighten down the cam plate bolts and tighten down the oil pump bolts. And that way we get both the oil pump and the cam plate centered to the crankshaft. We know that the crankshaft has 4.5 thousandths run out, so we want that oil pump and the cam plate as centered as possible to that run out. And so we've got a little leeway in with the bolt holes on both parts, and so by rotating the engine over, that gets everything centered as possible. Okay, we've got the Feuling cam plate assembly installed. We centered the bolts or the cam plate and the oil pump by rotating the engine over while we tighten the bolts down. We got Feuling part number 8015 along with the ARP optional bolt kit installed. Okay, so what we got going on here is we're going to line the sprockets up, the cam sprocket to the crank sprocket. We're going to check the, the offset of the cam sprocket where we can adjust it with the factory washers. And so what we want to do is get the sprockets running as true as possible, because that way the chain wear against the tensioner is going to be optimized.
I'm going to jump in here quick because it gets kind of technical. We always have a little bit of cam thrust, and we want that for end play in our cams because of our hydrodynamic wedge on these cam plates. We still need to optimize this alignment. So what we want to do is check it in two positions. We pull the thrust out, slide across our big gear, see that we have a gap on our small gear, showing us that our big gear is now out just slightly, a little bit. We're going to push it in, see what the alignment is. We should touch the gear. We don't touch it. What we need to do then is we need to take this gear off, measure our washer, go to a smaller washer, move our big gear in just slightly, and it'll line our chain up just a little bit better.
Another note is you can see that the crank bolt is in. We set that up without the washer on there and just enough tension to hold it tight. Okay, so here we are. We've got our selection of washers from the Harley dealer. We know that we needed a thinner washer. What we've done is we've measured up. We've got
140 on this one. We need a smaller washer, so we went to Harley, and the next one they have down is our 130. I'm pretty close, pretty sure that when we put this in, we're going to be back in alignment again.
So we check the thrust again.
We just touch, won't go on there. I pull it out, check the outer thrust, just slide over with just a little bit of gap. That chain is lined up perfect.
We're installing the outer cam chain tensioner. We're actually just reusing the stock tensioner and the bolts. We put a little dab of Loctite on them, and we're going to torque them up. Okay, we're installing the lifters. We saved the last one here to show you on camera, but you pump them up with an oil squirt can through the side feed hole, and we lube the lifter bores up very liberally and slide it down into place. Next we've got the anti-rotation pins to lay in place. We get a lot of phone calls about which direction the lifter should go as far as the feed hole. Our testing shows that it really does not matter, but if you want to put them one direction, I guess you can face them towards the crankshaft. We find that they might pump up just slightly quicker with the feed hole facing the crankshaft or the inside of the engine. Okay, we're installing the Feuling fast install push rods. We've started with the rear cylinder. We've got it on TDC. Started with the intake. We've already got the push rod adjusted to 0 lash. The key is to start with a fully pumped up hydraulic lifter. That way we know the push rod seat and the lifter is rock solid. We adjust the push rod out to 0 lash, which means we've got no play within the push rod between the rocker arm and the push rod. We don't want to go over the 0 lash because then you're already starting to adjust the push rod. And so what we did is we marked the push rod at 0 lash. You can tell by the little red marks there. And now we're going to adjust the push rod 3 1/4 turns longer with our 32 threads per inch push rod is going to put us right at 100 thousandths of preload. So this is the first of the 4 we're going to finish up. FeulingParts.com. Okay, we've got the engine buttoned up, got the cam cover back on. We used Feuling ARP 12-point dress-up fasteners on both the cam cover, lifter blocks, and up on the rocker boxes here. So we look sexy. We're going to install the air cleaner and then get on to the exhaust.